Hi YouTube, this is going to be an update on my robot project. There's been quite a lot of additions since the last video, and also, as I'm sure you've noticed, this video has sound. So I'm just going to jump right into it. Since last time, I ended up adding to the bottom of the robot another support chassis. As you can see, this bar goes along the bottom and is attached to the main body. These two supports, and then this is attached to the individual servos. It might be a little bit difficult to pick out in the video, but those are spacers from the Erector set, and those are super glued and then hot glued in place, and then there's just a screw moving or positioned in the center, and that allows the servos to move freely, but also provide support. Previous to this, as the robot would throw, weight was applied to it, the arms would bend down, and it was getting a really sloppy motion that way. So this way, it's a lot more stable. And I'm just going to go over all the parts again, just because we didn't have voice for the last few videos, so it was difficult to pick out from the video exactly what I was trying to illustrate. The robot's powered by an Arduino Uno, which is the bottom board here. See that? It's down there. And that runs the code. And then on top of the Uno is mounted, this is the Adadruit 16 Servo Shield. And it allows you to attach up to 16 servos, and the Arduino communicates with the board via I2C interface, which means the Arduino itself doesn't have to do very much processing to control the servos. It just sends a 8-bit number to the Servo Shield, and the Servo Shield decodes that number and provides the correct pulse width to the servos. I did in the code have to convert, it's easier to work in angles, so the code gives all the positions in angles, and then before it sends it to the board, it converts those angles to the individual pulse length. And actually, each servo had to be calibrated individually, because a pulse length of 500 on one would move to about 160 degrees, where on a different servo it might only be 140 degrees. So they each had to be calibrated individually. Alright, and then the next big piece is right here. This is hobby voltage. It's a switching power supply. So it takes the voltage of the battery, which right now is 11.6 volts, and steps it down to 5 volts. It's a switching power supply as opposed to a linear regulator, which is on board the Arduino. The advantage is that it's very efficient. It's better than 95% efficient, whereas the linear regulator, depending on voltage, is if you're very different in voltage, can be very inefficient and also produce a lot of heat. And then the battery itself is just a hobby battery for remote control car, remote control airplane. It's 100 milliamps, 3-cell lipopoly battery. It runs from anywhere from 10.5 volts up to about 12.5 volts is the operating range. And this battery powers all the components of the robot. And this right here is a wireless dongle for a PlayStation 2 controller. This would be the part that would actually plug into the PlayStation 2, and I just used some pins to connect it to the Arduino, and there is an available library that makes it basically plug and play. If you just follow through the library, it communicates with a serial bus between the Arduino and the host, and the controller receiver, and it basically just in the code you can query for whether the button is pressed or not. Makes getting your project remote controlled and wireless very easy. And this is the controller I ended up using. It actually was very cheap. It was like $10 on eBay, and it works great. One thing I will say, depending on what controller you get, sometimes you have to level shift. These are supposed to operate at a nominal 3.3 volts, but often you can get away with running them just 5 volts. And I actually bought a level shifter and put it in the first place, and it wouldn't work, but then I just tried running it right off the 5 volts, and it worked fine, so I'm just going to leave it at that. Alright, and let's see how it works. So I have the movement is for the most part controlled by the left thumbstick, and oops, turned off on me. The left thumbstick forward will move forward, and backwards will move in reverse. And then you can turn in place with left and right. And then if you go at an angle, you will move while turning, which gives you more of an arc to turn. And beyond just the movement functions, there's also some functions to control the robot's stance. So if I hold this button, the legs will spread out, and then on the other side, the corresponding button, the legs will go up, and then you can also go in, controls the angle of the leg, and then I can also lean to the left or right, and then forwards and backwards. And what's interesting is you can actually, the way it's coded is it will attempt to move while holding these positions. So if you're trying to move over, difficult terrain, there's like a hole on one side or something like that, it's actually able to get over it, and it works pretty well. Works surprisingly well, actually. And then if you want to reset the position, you hit the left thumbstick, and that resets to just the default perfectly upright position. And then there's also, you can move the shoulder joints forwards and backwards, and it's the same way it'll hold these positions as well. Select is a global reset, and then you can also, with the thumbstick, you can, if you get a position you like that's working well for the train you're on, you can record that by holding X and then pressing. And now if I change and I hit the button, it will go back to that pre-recorded state. And there's one other thing that is adjustable, and that's the speed. And the speed is adjusted by decreasing or increasing the cycle, like how long it takes in seconds for the robot to complete one step. And that's done by holding the I should have to double check. I haven't been playing with this for a while. Oh no, you don't need X for this one. That's right. So that's good. So we go in this, and this is at a slower speed. And then if I hold this, you can see the time decreases. And that will also be saved in your, if you save find a speed and position of the legs you like, you can save that as well. Right now, it's the robot uses a it's called a tripod gate, and it's the most common in the insect world. And with this gate, I'll slow it down real quick so you can kind of see. At any one time, there's going to be 3 legs on the ground, and then 3 legs that are advancing their position. And by alternating It's very stable because you always have 3 legs on the ground. It's very unlikely you're going to tip, and it's relatively fast. And it can be, if you increase the speed of the gate, it obviously speeds up quite a bit. And as of right now, there's nothing mapped to the right thumbstick. Eventually, I'm going to have a camera mounted, and the camera's point of view will be controlled, so looking down and up and left and right. But that hasn't been implemented yet. And also, the buttons don't really do anything. The X button is used as a shift to toggle for the D-pad and the shoulder buttons. It will perform different functions if you hold the X button. Alright, and I think that's everything for right now. And hopefully I'll get some more work done on this, and we'll have the next video will be a point of view perspective from the robot as it moves.